Hi, Chaitra and Manvita. For today's session, we'll start with the doubts. Do you guys have any doubts that you guys faced during the last sessions?
Yes, ma'am.
Yes. You can just unmute
Ma'am, can
yourself.
you? Yes, ma'am. Ma'am, can you please, in last session, you have taught us about beta diversity. Can you please again? Can you please repeat about the Primonova analysis using kind two? I didn't get that much. So,
I didn't quite get your question. You want me to explain the Prem ANOVA analysis, right?
yes, ma'am. Primonova analysis.
Hi, Chaitra, can you hear me?
Yes, ma'am. I can. Can you hear me,
Yes.
ma'am?
Yes, I can
Yes.
hear you. So in the last session, you want me to re-explain the Pernova thing. Pernova. One
Eh,
second, just let me
Yes,
share
ma'am.
my. Yeah. Did you understand the concept of beta diversity basically? Like why are we using beta diversity and the difference between alpha and beta diversity both?
Yes, ma'am. Yes. To
Okay.
measure two different samples,
Yeah.
we are
So
using
basically,
beta diversity.
yeah. So basically in beta analysis, we are trying to measure the diversity for two different samples. Mm, one second. This Permanova analysis was in alpha diversity, right? That you want me to re-explain.
Yes, ma'am.
Okay. So basically, I'll just share the slides once so that it's easier for you to understand. Yeah. Can you see my screen?
Yes, ma'am.
Yes,
Okay.
yes, ma'am.
So when we are doing the alpha diversity part, so just one sec. So when we are doing the alpha diversity, so we are trying to measure the diversity within a sample. So now to check is this diversity significantly statistically significant. That is when we undergo all these analysis. So this is one type of analysis that we are doing here, that is Permanova analysis, where we are basically trying to find any correlation between the data that is present. And these are the tests that basically give us an idea that are the groups similar or are the groups different from each other. So when we do this Paranova analysis in alpha diversity, what I showed you is that we get certain plots. See here we are getting for faith group and faith PD and for evenness. So basically in this downstairs, you can see that initially they have shown a box plot and here they have uh, performed the analysis. Yep. So this is basically what I want to mention here is that the analysis basically is telling that when you are comparing two different groups, that is group A and group B. So here we are just talking about the species that are present in a particular sample. So in that particular thing, we are basically getting how much percentage, like it is telling us the p-value. P-value and the null hypothesis is basically these are the tests. So there are two hypotheses that is given. One is a null hypothesis that says that the organisms are similar, and the other is a alternate hypothesis that says that the organisms are different. So these hypotheses can be accepted and rejected based on the p-value. If the p-value that we are getting is less than 0.05, that means the results are statistically significant and the organisms and the samples are different. But on the other hand, if we get a p-value greater than 0.05, that means that the groups are significantly similar and they're closely related, and the differences cannot be much told because those are not very differently related. Increased p-value basically says that the organisms that are present are quite similar, and the lower p-value is basically telling that they are a little different. So that is what is happening here itself. We're using this particular analysis. So here we are doing a correlation test because we are incorporating our metadata as well. Because in metadata only the feature IDs that we are getting in the results, that feature ID should be related to what biological sample it is coming from. So that and this is getting correlated, and based on these the values, we are basically statistically analyzing that is our basically the data statistically significant or not significant. So when you do further, um, I'll just explain you with this particular example. So I'm sorry that it was not alpha diversity, it was beta diversity itself. So beta diversity here, what was there? We had different groups, right? This was basically we are trying to correlate gut with all the other samples, that is gut, left palm, right palm, tongue. So here we have calculated and we have performed the Paranova analysis where we are statistically comparing all of them. So when you compare gut with left palm with all the values that are there, you perform a statistical analysis, and based on that you get a p-value of 0.01. Here you can see that the p-value is way less than 0.05. That means that the microorganisms that are present in the left palm and the gut, they are quite different. And that does make sense, right? The organisms that are present in the gut should be different from left palm because the environment is different, the function is different. And this does make sense here as well, and this results get validated because it shows that these organisms are significantly different, and it should be different as well. So both the, like, from our knowledge, from our basic knowledge, we understand that the microorganisms should be different, and this is getting proven by p-value as well. But if we are working with some de novo analysis, we might not know the understanding beforehand. Like here we knew, like if for this result, if gut and left palm showed a very high p-value, that means the samples have closely related microorganisms, then we could have understood that there is some problem with the data or analysis, because it should never happen, right? The gut and the left palm have different microorganisms, and if our analysis is showing that they're same, that means there is some problem with our analysis, because it shouldn't happen like that. But here we can see very clearly that the p-value is way less than 0.05, and it is very clearly telling that the microorganisms are different. And based on this particular thing, these group plots are also there, where you can see that the distance between the gut, like the distance for the gut microorganisms, is way different from the microorganisms of left, right palm, and tongue. They have a higher distance, rather they have a lower distance. So when we are comparing gut distance to all the other, we are understanding that these have a larger distance. That is why these are differently and distantly related organisms. Similarly for Paranova as well. And here you can see there is one value, that is 0.782. This is way higher than 0.05, right? And you can see in which comparison is happening between left palm and right palm. So this makes it more clear that if the p-value is high, then the microorganisms are closely related, and for left and the right palm, obviously they should be related. And it was also validated here by the p-value results as well. So basically, Paranova is just a thing that it is a statistical analysis test where you are statistically determining the significant groups and correlating if they are related or they are distantly apart. And based on the p-value that you get, you can accordingly state the hypothesis, that is, they're significantly similar or they are different, and you can reject and accept accordingly. Do you understand, Chaitra?
Yes, ma'am, I understand now. It's on last class I got confused about regarding p-value itself. So,
Okay, okay. Is it clear now?
yes, ma'am, yes.
Okay, good. Any other questions?
Yes, ma'am.
Yes.
Ma'am, when we have to export our tree to the Nuvik format for tool like ITOL, like are there any parts of the metadata that can get lost once we leave the QZF format?
Your voice is coming very slow. Just can you repeat the question once again? I understood the Nuvik part that you have to export.
Uh, yes, ma'am. Once we export it to the Nuvik format, are we
Yeah.
going to lose any part of the metadata we are carrying once we leave the QZF format?
Like what I understand from your question is that you're asking that when we convert the entire thing into a Nuvik format, is there any metadata loss?
Yes, ma'am. Are there any slight changes in the data which we carry?
See, the changes shouldn't be there because when you are converting into a Nuvik format, that Nuvik format that is getting generated is basically based on the distances of the microorganisms that are present. And in the metadata, basically, we are getting to know that for a particular feature ID, what is the sample. That feature ID is correlated to a sample ID, and that sample ID has some like from where the sample has been collected. So when the conversion is happening to the Nuvik format, so the only thing that's happening is that you're making constructing a tree. That tree is basically getting constructed based on the distances of the microorganisms that are present. So basically, it is just checking that are those microorganisms closely related or are those distantly related. So if their branch lengths, it is giving like a larger number. I told some matrices that they used to create those particular trees. So if the distances is more, then it is distantly related, and if it is smaller, then it means that it is closely related. But as you're converting into a Nuvik format, the metadata, I don't think there's any change in the metadata because metadata is just getting correlated to name the feature ID and to understand the distances between them. And then in Nuvik format, basically it is giving us some code that we upload in ITOL website, so where you can just observe the phylogenetic tree that is getting generated. And that
Okay,
distance, I would
ma'am.
just like to add one more thing, and that distance that you are getting like basically calculating is by initially you perform a MSA, that is a multiple sequence alignment. When you perform that with each and every organism, you basically get how much they are closely related to each other, and based on that further the distances are calculated and the tree is constructed. Is it clear?
Okay, ma'am.
Okay.
Yes, ma'am.
Any other questions?
Yes, ma'am.
Yes.
Like, can beta diversity alone can be used when we are handling the disease samples? Like, do we need any additional analysis step for the disease samples?
See, when you're doing disease samples and when you're analyzing them, it depends upon your objective and your goal, what you want. So, beta diversity here, like what if your goal is to basically you have a diseased individual and you have a normal patient. If you want to understand the difference in their microbial communities in a diseased patient and in a normal patient, then you can use beta diversity to identify the microorganisms that are different, like the diversity in both the samples, like in both the individuals, the way it happened for our moving picture tutorial. So it can be used, basically beta diversity is used to compare between two samples. So if you have that particular objective, then you can, yeah, definitely go with beta diversity. But if you want to understand the disease and the normal sample, then like what I will say that it depends on your goal. If your goal is to just understand the relation between them, like are those closely related or not, then you just ended for phylogenetic analysis. But if you want to understand that how the microbial communities are different in patient A and in patient B, for that particular thing you need to have a beta diversity analysis. And if you just want to check which and all microorganisms are present in one individual, for that you just do alpha analysis if you don't need any comparison. But if in your aim, if you have a comparison anywhere that you have to compare between two different species or two samples or two individuals, then you generally go for beta diversity analysis.
Okay, ma'am.
Okay. Any other questions, guys?
No, ma'am.
Chaitra?
No, ma'am.
Okay. So I hope till beta diversity it's clear.
Yes, ma'am.
Okay. So now for our kind pipeline, we have almost covered like the most of the pipeline. Now it is nothing much. It is just some PCOA plots that I showed you in the last session. I will talk about the theory of PCOA in the next session. And apart from that, we'll be just visualizing a taxa bar plot. That is the last major step that is remaining in our kind pipeline. And then we'll be done with it. So now for today's session, I asked you guys like if you want to study the UPGMA and NJ. So I will be teaching only UPGMA 3 today because of the time constraints. So what we'll do is you guys should be ready with a copy and a pen. So today no coding things happen. What we'll do is I will give you a distance table. So basically that distance table generally comes when you do a multiple sequence alignment of the organisms. And when you do an MSA, you will get how closely and how closely these organisms are getting related based on the distances, and you construct a distance table. So when you construct a distance table, now based on that particular distance table, you will have organisms, and then you have to construct a tree. Do you guys remember using? I told in the session that UPGMA constructs a rooted or an unrooted tree.
Yes, ma'am.
Which one does it construct? A rooted or an unrooted?
Unrooted, ma'am.
UPGMA always constructs a rooted tree. Okay. And then I mentioned certain factors about it, that it constructs a rooted tree, and then it is always following the molecular clock because that is the all the organisms are evolving at a constant rate. That is pretty hypothetical, and we don't need to look into that into much picture. So basically this is how your UPGMA tree ka, distance table looks like. So you have organisms A, B, C, D, E, and F. Okay. So you guys should be like handy with your copy and pen. I will be asking, you need to solve it so we can construct the entire UPGMA tree. Okay.
Yes, ma'am.
Okay. So for this particular thing, so I will just first tell in like overview of a UPGMA tree. So UPGMA tree is basically, it stands for unweighted pair group method with arithmetic mean. UPGMA trees always results in a rooted tree, and it basically assumes that it follows a strict molecular clock, that is all the species evolve at the same rate. So this is how your rooted tree should basically look. That is, you should have a root, that is a base ancestor from where all the other species are getting evolved. So our tree should look like this. So now this is a distance table. So we have 5 species here, A, B, C. Sorry, we have 6 species here, A, B, C, D, E, and F. So we haven't written A with A because obviously B with B should be 0. There should be no distance between B and B. They are exactly the same. So that is why half of the table has been left blank, and that is why there is no A here, because A with A will be 0. And A is given here for the other species. So A with B has a distance of 5. B and C has a distance of 7. A and C has a distance of 4. Can you understand the table? What does it represent?
Ma'am, basically, it's referring to the distance between the two
Yeah,
samples.
yeah, that is, yeah. So that you understood. So now you understood how to read this table. If I ask you, what is the distance between A and E?
Ma'am, it's 8.
A and E.
6, ma'am.
Yeah, 6. So A, we'll check for A and then we'll check for E. So we have a distance 6. Similarly, if I ask what's the distance between D and F?
It's 11.
How is it 11? D and F. See, D
Ma'am, 9.
and F. Yeah. So
Ma'am,
this
B
is,
and F or D and F, ma'am.
yes. What? Can you come again?
Ma'am, it's B and F or D and F.
It is DF distance.
Oh, sorry, ma'am. I thought it's B, not D.
Okay, okay. So B and F, if you have to see, it is 11. Yeah. and DNF it is 9. So understood. That part is clear. So now you understood how to read this particular table. So now our next step is basically to construct a tree like this, like distances between the samples. So in the distance table, the first thing you have to do is that you have to find the distance, like the species that have the least distance. So here, which and all species have the least distance?
Ma'am, A and B.
And C.
A and C. So that is the minimum distance, that is 4. So if it is like this, what we will do is we will write A and C, and the distance is 4. We will divide the distance 4 by 2. So we'll write A, C. We will connect them with a line, and obviously there will be a root, and the distance is 4. So 4 will be divided by 2, and then you can, because here we are considering a molecular clock, you understood that every species is getting evolved at the same rate. So we divide 4 by 2, that is giving both of them equal rate of evolution, that is the branch length is equal. So we construct a one part of the phylogenetic tree. Did you understand how A came with C?
Yes, ma'am.
Okay. So
Yes,
now,
ma'am.
okay, so the branch length for both of them is 2. So now what we will do is we will construct another table where, because we have already combined A with C, right? Now we cannot write it in the distance table as a separate A and C. So what we will do is we will combine it like this. So it will become AC. Here also it will become AC. And the components of C and A that were separately present now should be only combined and present. And individually A and C will be removed. So on the in the top row it was A, B, C, D, E. Now it became A, C, B, D, E. C is removed because C came with A. And similarly in this column also it was C. Now C is removed and it became A, C, B, D, E, and F. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. So now what we have to do, this was our original distance table. Now we have to create a distance table for this particular table that we created. So how will we create? So we know the distance between B and B. What is the distance between B and B?
0.
Yeah. And then between, you guys should make this table right now. And you need to fill this table. I will just tell, like, make it simultaneously. And then what is the distance between B and D?
10.
10, ma'am.
So it will be easy to fill for BDE because it is already given in the before table. But how will we calculate the distance between AC and B? So it's written here. So distance between AC and B will be calculated as distance between AB, that is AB, that will be 5, plus distance between BC. B and C, that will be 7. So it will become 5 plus 7 divided by 2. That is 12 divided by 2, that is 6. So AC and B should have a distance of 6. Did you understand?
Yes, ma'am.
Yes, ma'am.
Okay. So now I'll give you 5 minutes. You need to calculate the distances for all of them and tell me.
Okay, ma'am.
Okay. If you have any doubts, you can just stop and ask. Okay. I'll give you 5 minutes. Calculate it.
Yes, ma'am.
Is it done, guys?
Ma'am, can you give us 2 more
Yes,
minutes?
ma'am.
Okay, okay. Take 1 more minute.
Yes, ma'am. I'm done.
So can you just tell me the values? What will it be? For AC to B, it's 6. Can you just check once? Is your value similar to this particular table?
Yes, ma'am.
All the values?
Yes, ma'am.
Okay. Manvita?
Ma'am, ma'am,
Yes.
ma'am, is it okay to add zero if we write zero in blank areas? Is it okay or not?
Yeah, that's absolutely okay. If you won't write anything also, it's fine. And if you write 0 also, that is fine. It's just the blank
Okay, ma'am.
spaces because, see, full you cannot write 0, okay? So B and D.
Ma'am, there is a constant lag from your microphone.
Here, because we are already writing B with D here as well.
Yes, ma'am.
Okay.
Yes, ma'am.
So I'm saying you cannot write 0 for all the blank spaces because you can only write 0 in this particular diagonal. That is AC with AC, B with B, D with D, E with E, and F with F if coming here. Here on the above triangle, everything will be repeated. This numbers will be repeated here as well. So that is why it is left blank. But otherwise, it will become too confusing. Okay.
Okay, ma'am.
Okay. So now you have constructed this table, new table. So in this new table, which two species have the least distance? Are you able to hear me, guys? Are you there?
Yes,
Yes,
ma'am.
ma'am.
It's with D.
It's with D
D
and
and the E.
yeah, D and E, this 5. So we'll do similar thing as D and E is not related to A and C. So you will make a separate tree like this and you will write D, E and the distance is 5. So 5 divided by 2, that is 2.5 and 2.5. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So now this is the new table. So now you have taken D and E as 5 and then you have written it as written it like this. So now they can't stay as D and E here separately. So they have to become like this. So now again the table will change. Initially it was AC, B and DE. Similar this way as well, B, DE and F. So now you need to again calculate the new distances from this particular table. So distance between AC and B is already mentioned in this table, so you can do it. The only thing here you have to calculate is the distance between DE and F and the distance between DE and B. So how will you calculate that? So DE and B, if I say, so first you will take distance of D with B and then you will take distance of E with B. That is 9. So it will be 6 plus 9 divided by 2. Did you understand?
No, ma'am. Can
Ma'am,
you
can you
repeat
come
it
again,
once?
ma'am?
Okay. So initially we for calculating the distance of AC with everything, so we calculated distance of A with B, and then distance of B with C, right? Similarly, what we will do here is to calculate the distance between AC. AC is though there, everything. So to calculate the distance between DE with say F. So what you will do is you will calculate first distance between DF plus distance between EF divided by 2. So that will be like this: D with F first, then E with F, then the entire thing is divided by 2. So here D with the F is 9, E with F is 8. So 9 plus 8 divided by 2. That will be the distance between DEF. Did you understand?
Yes, ma'am.
Okay.
Yes,
And
ma'am.
similarly here, if you have to calculate a distance between AC and DE, so what you will do is distance between AC with D and AC with E. That is AC with D and AC with E. That is 7 plus 6 divided by 2. So can you calculate the distances and tell me? You have 2 minutes to do it. Is it done?
Yes, ma'am.
Okay. So I will just show the values. Are the values similar or is there any difference?
Yes, ma'am. Same, but we did only for DE.
Why did you do just for DE? I asked you to construct the entire table.
Yes, ma'am. I got the value 6.5, 9.5, and 8.5.
Okay. And rest is this. Okay, great. Both of you got right?
Yes, ma'am.
Yes, ma'am.
Okay. So now new table. So before this, our table was this, and we had these two branches. So now from this, you tell which one has the least distance.
Ma'am, ACB.
ACB, right? So now here you can see our AC. So now to this AC, we will attach another B as well. So it will look like this. Okay. So now our AC is related with B. So here AC and B distance is 6. So you divide 6 by 2. So this branch will get 3 and the upper branch should also get 3. So this branch is already 2. So this smaller branch will get the distance 1. The collective distance should be 3. Understood?
Okay, ma'am.
Okay. So this is how you put B as well. So now ACB is together and DE is together. So DE is already here. So now what you will do, you will club AC with B now, because AC is now with B. So new table will be formed, that is ACB and then DE. Here also it will be DE and F because B is now combined with AC. So now the new distance that you need to calculate is ACB with DE and ACB with F and then DE with F. So you already know that is 8.5, right? If you follow the same procedure, that is 8.5 here, and ACB with DE, if you have to calculate, you will calculate that is AC with uh, for DE, right? AC with DE plus B with DE. That is 6.5 plus 9.5 divided by 2 will give you 8. And similarly for AC, B and F, you will calculate AC with F and B with F. That is 8 plus 11 divided by 2. I hope this is clear, right? It's just an iterative process. You have to keep going.
Yes, ma'am. We got to know now.
Yeah. So now this here, the smallest distance is ACB with DE. So now you are going to combine ACB with DE. That is, this branch will get connected to this branch. And 8 divided by 2 will be 4. So here 2, 1 is already there, 3. So this branch distance will become 1. And here it is 2.5. So it will become 1.5. See. Understood? You connected them now. Okay, because it was the branch distance was 8. So now ACB is connected to DE. So now you will combine all of this to form ACB DE. ACB DE with F. So now for the past thing you had ACB DE is combined. So now on the left hand side, that is this column, only F remains. So now the entire thing, that is A, B, C, D, E, should be analyzed using like in correlation to F. So when you construct this table, so what you will do is you will calculate the distance of F using this table. That is ACBDE with F. That is ACB distance to F 9.5 plus 8.5 divided by 2. You will get 9. And now you know you can connect ACBDE with F. That is this entire thing with F by this connection. And 9 divided by 2 is 4.5. This entire branch length will be 4.5. And this will be 0.5 because it comes out to be 1, 2, 3, 4. If you calculate from any of it, it will be same. If you take this 2, 1, 1, 4, 3, 1, 4, 2.5, 1.5, 4, and it becomes 0.5. So you understand this is how a UP geometry we construct, and this will be connected to a root. So this is a rooted tree, and you constructed this entire tree using a distance matrix. That was this. So this was a distance matrix that was given, and you were asked to construct a tree, and you basically correlated how this ABCDE basically looks when you put it as a tree. Is it clear? Did you understand how to construct a UP geometry?
Yes, ma'am.
Yes, ma'am.
Okay. So only I'll teach the UP geometry for today's session. In the next session, we can, in any other doubt session, we can understand how we construct basically our NJ tree. So NJ tree basically looks like this. Like it is not a rooted tree, it's an unrooted tree. So the distance table will be same. We will construct an unrooted tree for it, but it has a little complex steps where basically this slide we have to follow. You have to calculate star distances and all of that. So that we'll do in another session, any session that is free. So you guys tell me on for any session if you want me to put this NJ, we can study that as well. For today's session, only UPGMA and the doubt session. Like, is it clear how are we constructing a UPGMA tree? That's just there.
Yes, ma'am. We understood.
Yes,
Okay.
ma'am.
And if you guys have any other doubts,
No, ma'am.
so just
No,
practice
ma'am.
once how to construct geometry. It's very easy. And if you guys have no more doubts, then maybe we can end the session for the day.
Yes, ma'am. Ma'am, could you share this PPT in the group?
Yeah, I'll share this presentation. Do you want me to share the entire thing, or I'll just share the UPGMA part?
Just the UPGMA part, ma'am.
Okay, I'll share the
Ma'am,
UPGMA part.
also, the last session PPT you didn't share us.
Yeah. I'll upload that also. After the session, I'll upload it.
Shivanshu, should we stop the session?
Yes, sir. That's for
Okay.
that's for it for today's session.
Okay, and Chaitra and Manvita, please update your feedback in the Google Form, okay? The same
Okay,
Google
sir.
Form.
Yes, sir.
Okay, thank you.